Okay, so today we're going to look at section 8.1, which we're going to look at sequences and summation notation. We'll also look at something called the factorial. This will be broken into two videos. First thing we're going to start with is just understanding what a sequence is. A sequence is a list of numbers that follows a specific pattern. So in this case, we have this sequence right here, 3, 6, 9, 12. You can see that they're adding 3 each time. You could think of this as the pattern is 3n, okay? Because if n is 1, 1 times 3 is 3, n is 2, 2 times 3 is 6, so forth, so on. The second sequence that we have here is called the Fibonacci sequence. What happens is you start the sequence with 2 ones, and then the next term is the sum of the 2 previous terms. So this is a recursive. You have to use not just the previous term, but the previous 2 terms to figure out what the next term is. So we start with 1, 1, and then 1 plus 1 is 2. That gives us our third term. And then 1 plus 2 gives me 3. And then 2 plus 3 gives us our next term, which is 5. And then 3 plus 5 gives us 8, and so forth and so on. In the notation, a sub n just means a sub 1, a sub 2, a sub 3, etc. until you get to a sub n. And that just means that that's just a name for each of these terms. So in the first one, we would have a sub 1 would be 3. A sub 2 would be 6. A sub 3 would be 9. And it just gives a name to the terms. And we can actually write and find the terms of a sequence. So in number 1a, we're going to write the first 4 terms of the sequence. So that means we're going to find a sub 1, a sub 2, a sub 3, and a sub 4. Okay, so a sub 1, we substitute in a 1 into this equation. 2 times 1 is 2. 2 plus 5 is 7. Okay, for a sub 2, we're going to substitute in a 2 into the equation. So it's going to be 2 times 2 plus 5. So that gives me 9. The next one's going to be 11. The next one's going to be 13. Okay, you can substitute each one in to verify and check. 2 times 3 plus 5. That's 6 plus 5. So 6 plus 5 is 11, etc. For part B, we do the same thing. We have a sub 1. That's going to be negative 1 to the first power over 2 to the first power plus 1. So that's going to be negative 1 to the first is just still negative 1. 2 to the first is 2 plus 1 would be 3. A sub 2 is going to be, we're going to get negative 1 squared, which will make it a positive, and then 2 to the second plus 1. So that's going to be a positive 1 over 5. Okay. A sub 3, by the same process, would be negative 1/9. And for a sub 4, we would substitute in a 4, and when you do so, you get positive 1/17. Okay, so then it asks us to find the 53rd term in the sequence. A sub n equals 2n plus 5. So a sub 53 would be 2 times 53 plus 1. So 2 times 53 is 106 plus 1 equals 107. Okay, now part 3, question 3, where we have find the first 4 terms of the recursive sequence given by a sub 1 equals 5. So they give us a starting term, and then they tell us that a sub n equals 3 times a sub n minus 1 plus 2. This right here means we have to use the previous term to find the next term. So if I'm looking for a sub 2, that's going to be 3 a sub 2 minus 1. Well, 2 minus 1 is 1, the term right before it, plus 2. But we know what a sub 1 is. A sub 1 is 5. So we're going to do 3 times 5 plus 2, and that gives us our a sub 2. So on this one, a sub 1 they gave us, it's 5. A sub 2 is going to be 15 plus 2. 15 plus 2 is 17. A sub 3 is going to be 3 times 17, our previous term, plus 2. That's 51 plus 2, so that gives us 53. And a sub 4 is going to be our previous term, so 3 times our previous term, 3 times 53 plus 2. 3 times 53 is 159, plus 2 would be 161. So a sub 4 is 161. So just keep track of the recursive sequences. They'll always give you that starting value. In part 2, we're going to look at factorial notation and summation notation. And then we'll see some examples of the summation notation and how to calculate the sums based on that. Thank you.